This is a national NC-57. It's been trying to get it to work correctly on the highest band, band A, which tunes from about 35 to 54 megahertz, which is kind of pushing it a little bit for a design like this. It's not really a VHF design. Anyway, after a lot of work, I have managed to stabilize the oscillator on that band and stopped it having spurii, and it now doesn't drop out at any point on the band. It's constant and steady across the whole band. The only negative is I can't quite get it to align at the highest end. It's about a megahertz or so out at the highest end, no matter how often you sort of squeeze this little coil together or open it up or tweak the trimmer. So I think I'll have to leave it at that. Just to say what I did. In the local oscillator circuit, I put a disc ceramic bypass capacitor in it, with very, very short leads, soldered to the tube base. I soldered the tube bases, the RF amplifier tube and the local oscillator converter tube, to the chassis. I added a ferrite bead to the RF input capacitor to the RF amplifier. I changed out the stopper resistor, which is a 33 ohm, which had drifted high, about 45 ohms. It's now 33. I also put a ferrite bead on that lead there, which is onto the oscillator grid. I changed the one silver mica capacitor in the which is a padded capacitor in the band A. That had drifted from 100 picofarad to 185 picofarad, and also there was a tubular ceramic coupling capacitor, which was on value, but I changed it out anyway. But there's now, it's got a silver mica part in there. I also cleaned all the ceramic trimmers up, particularly the band A one. They were quite dirty, and I experimented with the coil, which is those couple of turns of thick wire, squeezing it in to increase the inductance and pulling it out to lessen the inductance. I think that's about it. Quite a bit of work. Anyway, just a quick demonstration of tuning across the band. The TinySA is measuring the local oscillator frequency, just kind of with a little RF probe just hanging about in the local oscillator compartment there, and the set is tuned to the bottom end of that band, which is about 35 megahertz. The local oscillator, I think, should track low of the receive signal on this band. I need to double check that. So at the moment it's oscillating about 34.9, which isn't correct, it needs tweaking a little bit. You know, just tune up the band, you'll see the peak move along the scale on the TinySA as I tune the band. And there shouldn't be any spurii or other weird effects like dropouts and things like that. And the last thing I did was put the original tube back in. With the new tube in with a higher transconductance in it. It had a little bit of a hissy fit around 47 megahertz and started to generate spurii sidebands on this signal. So that was interesting. This is the new 6SB7Y Westinghouse tube, and the original one that's in there was an RCA tube. And you can't really beat RCA or GE tubes, I don't think. These radios. Westinghouse, yeah, okay. But anyway, this is definitely high transconductance, brand new old stock tube. The other one was kind of marginal on the transconductance, but I'm going to leave it in the set because it's oscillating just fine, and it doesn't produce any nasties. Around about 47 megs. This is tuned to 47 megs now, and it's absolutely fine. No hint of a dropout. The oscillator does get a little bit flaky right at the upper end. You can see the amplitude's kind of dropping off a little bit. but it's there. And it goes up to 52.5-ish megahertz, so that would tune about 53 megahertz, and the scale goes up to 54, so it's a little bit out, but there's nothing up there anyway. There's no stations to receive. It's all a bit of an academic exercise just to find out what it needed to get this this set working on the band correctly. It's working fine on all the other bands. It's just the band A wasn't working right at the upper end. There you go, NC-57 band A sorted out.